Hey everyone. Thank you for joining us tonight. We have a very special guest, Seth Art. Seth is a principal at Bishop Fox. He's done a lot of work in the cloud space, very interesting projects he's going to be covering a couple of tonight. So we're very excited about this talk. I'll let him do a more formal introduction, but thanks everyone for joining. And Seth, take it away.
All right, thanks, Mike. So hello, everybody. Welcome to Hacking the Cloud. My name is Seth Art, and as Mike said, I'm a principal at Bishop Fox, where I'm currently the cloud penetration testing lead. My path to cloud penetration testing kind of started on the defensive security side. Then actually, when I lived in the Nova, DC area for a while, I got into application penetration testing. Then I was really intrigued by internal penetration testing and started doing some of those and just network penetration testing in general. And then eventually, about 3 years ago, I started to get really excited by cloud security and cloud penetration testing, and essentially bringing that internal pen test mindset and methodology to the public cloud providers, to Kubernetes clusters, et cetera. So today, I'd like to first define what I think of when I think of cloud penetration testing. I'd then like to kind of compare cloud pen testing to some other offensive security type services. Then I'd like to introduce CloudFoxable, a tool that we wrote at Bishop Fox to help penetration testers gain situational awareness of unfamiliar cloud environments. Then I'd like to share CloudFoxable. So this is a tool that we created. It's a gamified CTF hacking environment that you can deploy into your own AWS environment and learn the art of cloud penetration testing. So with all that kind of background, then I'd like to really, the meat of this presentation is in talking about some of our most common high impact cloud pen test findings. So not the low hanging fruit or the lows and informationals, but the stuff that really matters. I kind of go over some of those. And at the end, what I'll do is, after we kind of see some screenshots of those type of findings, I'd like to walk through using CloudFox against the CloudFoxable environment to kind of just show you a little bit of that process that we go through on a cloud pen test. So when I think of cloud penetration testing, or the way I define it, is that it is an assumed breach, objective-based, white-boxed penetration test. So what do I mean by that? With assumed breach, we are assuming that at some point a cloud-hosted application or service will be compromised. So we're not looking for the entry point in. That would be done by something like application penetration testing or external penetration testing. We're assuming that eventually something is going to fall. And then the same thing, we sometimes start from the perspective of a compromised or malicious user. So again, we're not worrying about the phishing side of it. We're not worrying about getting the foothold. We're saying if somebody was acting malicious, or if somebody was compromised and they have access to your cloud infrastructure, what's the worst that can happen? Next is an objective-based approach. So we define the starting points with that assumed breach mechanism, and then we define trophy targets. And this just helps us be more effective, right? Penetration testing is a time-boxed activity mostly. And so we want to say, where is the most sensitive information? Is it in an S3 bucket? Is it in a database? Is it an API that's an internal backend API? Helping us understand that that trophy target helps us find the attack paths more quickly. And on that note, I strongly believe in white box testing for cloud penetration tests. And this actually is born from something that you all are very familiar with at OWASP, which is source code review, right? I can't tell you how many hours I've spent, especially early on in my career, trying to break input validation controls, not having access to the source code, right? But if you have access to that source code, you can see, oh, here's the regex. It is or is not vulnerable. You can identify that so much quicker. And the same thing applies to the cloud. So what we do with cloud pen testing is we ask for a security auditor or read-only type access to all of the in-scope cloud environments. And that helps us just find more high-value attack paths more quickly. So let's compare cloud penetration testing against cloud configuration review using our make-believe cloud castle. So configuration review is generally kind of like a baseline check, right? A benchmark check. The most common, of course, is the CIS benchmarks. They benchmark all the major public cloud providers: AWS, Azure, Google, Kubernetes. There's a baseline for, and so let's say there's a CIS benchmark for Cloud Castle here. It might say something like you want to make sure that you have a drawbridge, a moat, walls, towers, knights, etc. Right? And those are really important things. I believe very strongly in configuration review. I think it should be automated. I think you should be doing it continuously. But it is very important because you don't want to overlook something that kind of, everybody else knows that this is what you should be doing. But we all know that you can have a fully compliant, an environment that passes the baseline that is still vulnerable to would there be an attack. And that's what cloud penetration testing is aiming to solve. So yes, you have all of these different defensive components, but if we put somebody in between the inner walls and the outer walls, is there a path to get to the objective, which is that bedroom in the main tower or in the main castle? Same thing. What if there's somebody starts inside the courtyard? Is there a path? And that's the purpose of cloud penetration testing. And you can make the same comparison with application penetration testing, right? So it is very important. It always has been and always will be very important to do your app testing on your individual components, your services, your apps that are publicly exposed, but also internal ones. Every company doesn't have the resources to test everyone, but that's a known problem, right? You test the things that are most important first. But even if you tested all of those apps, there's nothing saying that, tomorrow there's a new vulnerability that's introduced into one of those apps that allows the person to get this foothold, right? Or maybe there's a third-party component that is being used that just became vulnerable, and now the attacker is in between the inner and outer walls. So again, CPT helps you kind of harden up that center, that inner part of your infrastructure, just like an internal pen test. Okay, so to do this work, the main thing is that cloud pen testing is a clone, or it comes from internal pen testing, but it is very different. You need different skill set. You need different techniques and procedures, right? So CloudFox is one of many offensive security tools created to help cloud penetration testers. So I like to say it is an attack tool, but it doesn't attack. So there's no auto exploitation. And in fact, unlike a lot of baseline type tools, it doesn't even give you findings. It just, the purpose is to try to do the enumeration and give you breadcrumbs or threads to pull on that might lead to a very interesting finding. I'm a big fan of the kind of process of teaching you how to fish, right? So one of the cool things about CloudFox is that a lot of the commands, they don't do the auto exploitation, but they do give you the commands. Let's say there's a command, for instance, that lists all the S3 buckets in an AWS account, right? If you auto downloaded all the objects in all of the buckets, that would be very bad. It would take forever, or just not even finish, right? Some buckets have millions of files. Also, it would cost the client a lot of money depending on where you're downloading those files to. But looking at files inside of S3 buckets is a very important part of a penetration test, depending on if you have access to those buckets. So what CloudFox does is it enumerates those buckets and then gives you the commands so that if a bucket sounds interesting or looks interesting, you can list the files in that bucket, and then you could download an individual file as needed, for instance. And in some cases, sure, it might make sense to download all of the files recursively in a bucket, once you've kind of manually validated what's in there. So here's one of the CloudFoxable commands, or sorry, the CloudFox commands. It's the inventory command. So this one just gives you a lay of the land as a pen tester, right? We're often going into unfamiliar cloud environments on a point-in-time pen test. So it's really helpful to know, how many resources are there total, how many services are being used, what regions are being used, etc. And if you can see in the last line here, I kind of clipped it to fit into this slide, but all of the commands output to text, table files, CSV files, and JSON. Okay, so that's a quick introduction of CloudFox. We'll come back to it and see more. Here's a quick intro of CloudFoxable, which is a tool that we created. It's a Terraform project that you can clone, configure, and then deploy into your own playground AWS environment. The cool thing is that the gamification happens at cloudfoxable.bishopfox.com. So the first flag there, the thing you see at the top, that walks you through installing CloudFoxable. And then after that, you can kind of pick and choose these challenges and learn this art of cloud pen testing in the safety of your own account. So right now there are 19 total challenges, and it really focuses on realism over creativity, right? We're trying to recreate some of the things we find on pen tests, but it really does lack the creativity that you see in some CTF environments, kind of like creating a fictional company, things like that. All right. So now this is the meat of the presentation. Is I wanted to kind of show you what some of these high impact findings look like. So these are the 4 that I'm going to cover. The first 2 are interesting in that they're kind of like new to the cloud, right? They're kind of cloud native. There are certain ways you can configure things in the cloud itself, that can be overly permissive or allow for a privest path or an attack path. The bottom 2 are kind of not really how you've configured the cloud mostly, it's how you've configured your stuff in the cloud, right? And they're oldies but goodies. They've been around for way longer than public cloud infrastructure has been around. Insecure credential storage and missing auth and weak and default creds. So let's talk about this first one, overly permissive trust policies. So here we have the CloudFoxable roles trust command. And what this is doing is it's looking at all of the roles and splitting up into 3 tables. So I'm going to go through these tables real quick, but then I'm going to swing back to this one. So you have the role name, and then the first table shows roles that trust another principal. The next table shows roles that trust a service. And it's important to know a role can trust both a principal and a service, so it'll show up in both tables. And then here we have roles that trust a federated identity, something with SAML or OIDC, and we'll get back to that. Okay, so why is this in the most common high impact cloud findings, right? This is because the way AWS does role trust is very confusing. There's a lot of logic behind the scenes. So let me just walk through how some of the complexity there. So the first role, Alexander Arnold, you could see it can be assumed it's trusting the role CTF starting user in the same account. So the thing that is not obvious here is that CTF starting user could have no permissions whatsoever. No, they call them identity policy. There's no identity policy. There's no permissions directly assigned to CTF starting user, but they can assume Alexander Arnold, and that catches people by surprise sometimes. And then you have the next one, Beard. Now this role trusts root in the same account. Now this is a little different. People often think this is the root user, but it's not. This says Beard trusts every principal in this AWS account, can assume it, but here's the caveat here. That principal, because of this root notation, has to have the STS assume role permission. So you see these 2 they look so similar, but they act so differently. And so we often find, and if you look at the organizational account access role, you can see now here is a role in this account is trusting the root of another account. And so this leads us to cross-account attack paths often, and also intra-account privilege escalation as well. So the way the roles that trust AWS services work are, let's say you have the ability to create an EC2 instance, and let's say you have the ability to pass any role to it. What catches people off guard sometimes from the offensive security side is that you can't pass any role to an EC2 instance that you create. You can only pass one of these 4 here that trust the EC2 service. So really, if you're just looking about getting administrative access, there is no path to administrative access with creating an EC2 instance and passing a role, even if you have that permission. But if you look here, if you have the ability to create a Lambda function and pass a role, there is a path to administrative access. And then lastly, you have the trusted provider. So this is a really interesting thing here. So here we have a role, T Rodman, which trusts a repository, a GitHub repository, CloudFoxable Trust Me Demos, :*. And the way this is configured, I'm not going to get into this, but the way this is configured allows anybody with write access to that repository to gain access to this role, to essentially assume this role. So if this role can see every file in every S3 bucket, so can anybody with write access to that repository. If this role has a path to admin, so does everybody that has access to the repository. So there are a lot of sharp edges, as you can see. So the last overly permissive trust policy that I'm going to talk about is a resource policy. So with resource policies, these aren't on IAM roles. These are on things like buckets or lambdas or SNS topics or SQS queues. They can have policies on the resource itself that says things like, for the first one, anyone can SNS subscribe or SNS publish if you're coming from a particular IP. But let's look at this second one. So this is the executioner. So everyone can SNS subscribe or SNS publish when, and this is a condition. I'm basically translating AWS policies into human readable form, but when the AWS principal account is the count we're in. So what's the implication of this on the second line? Right, we're kind of talking about the assumed breach scenario where somebody's compromised a service of yours or an application, and now they have access to a Lambda, to an EC2 instance, to a pod, to an ECS container in your account. That means that any principal in this account, anything that's compromised in this account, can also subscribe and publish to this topic. And that might leak sensitive information, or that might allow a path for remote code execution, depending on what's consuming the topic. And actually, there's a finding like that in CloudFoxable. Okay, so let's move on to the next high impact finding, excessive permissions attached to workloads. I didn't really say this specifically, but I'm really focusing on this side of it. For this talk, focusing on the assumed breach of an application or service. There's a lot of other paths that have to do with a user who has access, assumed breach of a user, but we're mostly focusing on this scenario right here. You have a malicious user who has somehow, through some kind of RCE or some way, gained access to an EC2 instance in a production account. As we talked about in the role trusts table that we just saw, an instance can, but doesn't need to have a role associated with it. And if the instance has an IAM role associated with it, the instance has access to all the permissions that are provided by that role, which means that if you compromise an EC2 instance, you have access to all the permissions that are provided by that role. And this is where least privilege really matters, right? We often see an instance, or all of the instances have something like full EC2 access, so they can kind of have access to other EC2 instances. It's just overly permissive. It's almost never needed. Or worse, you can have something where the EC2 instances have unfettered access to all of the buckets. So what that means is if any instance gets compromised, the attacker is going to be able to get to the sensitive data in the sensitive bucket, right? So what you really want to do is you want to not have S3 get star on all buckets, right, and list on all buckets. This instance might need to talk to 1, 2, maybe 3 buckets, not all of them. So that's the case where you have a running instance in that case that was compromised, right? And then how you would exploit that. But what about this scenario? So here's CloudFox's Lambda command, and it's just enumerating all of the Lambda functions that exist. And you can see this first one has a Lambda admin role assigned to it, and that role is admin. So what's another way that we can attack this scenario? Let's say we've compromised something in the AWS environment that has the ability to update Lambda's function code, right? If you can update the code in this Lambda that is running as admin, then you are essentially admin, right? You can just drop code in the Lambda that'll, spin a reverse shell back to you, the attacker, or even just send you the temporary credentials from the Lambda function. So this is another reason why it's very dangerous to have workloads in production running with administrative access. Okay, so now let's get to one of the oldies but goodies, insecure credential storage. The way this manifests itself in the cloud is usually in environment variables for services that support them, or in files in S3 buckets. That's where we see them the most. Occasionally, you'll find a secret or sensitive credentials in a container image or in maybe a CloudFormation stack. But almost most of the time, they're in these environment variables. And it's important here because sometimes you might think, well, I'm going to give somebody read access, right? I'm going to give them list functions access for Lambda, but that allows them to see the environment variables, right? So even if they don't have access to the RDS database at all, if you've given them list function access and they can see the environment variables, which have, in this case, the RDS credentials, you've essentially just given them read-write access potentially to your RDS database. And that's actually one of the things we're going to do in the demo. All right, the last one. Missing authentication, weak credentials, default credentials. We see this all the time. It really is almost always this assumption that, I have this service that's not maybe publicly accessible, and only people that are trusted, that have VPN access to the VPC, that have some other network access to the VPC, only they can access these other services. But that, just like an internal pen test, that breaks down if your EC2 instance or your, a pod in an EKS cluster is compromised, because now the attacker has that internal network access. So here is a recreation of a real finding. The goal, we started as a compromised EC2 instance in development, and the goal was to get credit card data in production. And so with our white box approach, we were able to identify there was an EKS cluster. We used the Route 53 information, to enumerate services, and we found that there was a Jenkins service in the EKS cluster that was accessible to anybody in the VPC. So from our EC2 instance, we hit the Jenkins service. We found an endpoint that is called async people. It listed all of the users that were configured in the Jenkins instance and told us that there were 41 users. Now, sometimes we don't get lucky, and sometimes we do get lucky. This time we got lucky. We were password sprayed, expecting it to be kind of company 123 or something like that. But here we had the user that used their username as their password, and that user was an admin. So now we have administrative access to Jenkins in development. So the way on this test we got to production was that Jenkins had agents running in different accounts, and one of them was running in production, which means that if you have administrative access or access to run jobs and create jobs in the Jenkins in dev, then you can execute code on the agent in production. And if that agent has an IAM role associated with it, you have the permissions that IAM role has, right? So this is how we went from Jenkins in dev to admin in production. Now, I wanted to talk about this one first, but we have also found almost an identical situation to this multiple times, where this is kind of more of like a legacy attack path, right? The way we crossed from one account to another account was through Jenkins, through another service. But there's also cloud native ways that you can mess this up in AWS and in GCP and Azure. So for instance, we've seen the same thing where the Jenkins role, like where you don't even need the Jenkins agent in production, right? There could be a role in production that allows the role or the principal in development to assume it. And so again, we could have just gone from, in that case, we went from Jenkins to assuming the Jenkins service to assuming the Jenkins role in production, and again, getting, admin or whatever that Jenkins role had. But okay, back to this scenario. We had admin, but as we all know, as penetration testers, that's not the end, right? Because we didn't get just getting admin, we did have to do a little bit more hunting to get to the credit card data. We found the RDS password. If we didn't find the RDS password, we would have had to potentially do something even more risky, changing the password on a production database, which we probably wouldn't have done that, right? But we were lucky. We found the RDS database password in Secrets Manager, and we still couldn't even connect to it because there was a security group. So in this case, we could have just modified the security group, allowing the Jenkins agent to access the RDS database, but we didn't want to modify that. We found an easier, less disruptive path. We just created a kubeconfig with our admin credentials to gain access to the EKS cluster in production, which was in the security group already. And then from that network place, we were able to use the password, the credentials, and get to the database. And here we are showing the credit card table in the database. Okay, so that was a lot of talking. Now I'm gonna switch over and do maybe a 10-minute demo, and then I'll switch back and cover some takeaways. So, and feel free if you have questions, now is a good time. Feel free to just jump in. I have a couple of things that I have planned that we can talk about, but I'm happy to go off on tangents. So, so the first thing I want to show you is that I've already cloned CloudFoxable, and I've already actually deployed it, but I'm going to kind of show you what you would do. That first flag kind of says you clone the repository, you download the Terraform binary, you configure an AWS profile. You have to kind of create an administrative user if you didn't have one in this Playground AWS account. Please don't use any kind of production account for this. This is intentionally vulnerable stuff. And now what you'll do is you'll do a Terraform apply, which in this case will just confirm the state is the same as it was. But if you're running it for the first time, it would deploy hundreds of resources into your account. And by default, the ones that don't have much cost associated with them, like the serverless type stuff, like Lambdas and SNS and SQS, that stuff's all enabled by default. But there are some challenges that the ones that cost money, I actually enabled these just for this talk, and I'll disable them at the end of the talk. And I give you kind of a rough guide of what you would expect cost-wise. With the caveat that if you spin up a new account and you're in the free tier, you probably will have no cost associated with this at all. But let's see, what can we look at here? This table kind of just gives you a lay of the land, right? It makes sure you deployed CloudFoxable into the account you expected. This is the account I used to deploy CloudFoxable. This is the CTF starting user. This is the one that a lot of our attack paths are going to start from. And then this little bit here will help you configure a profile for the CTF starting user, since the Terraform is what created the username and password, or the secret and the ID and the secret access key. Okay, so the next thing I want to show you is simply the CloudFox command itself. All right, so the CloudFox command, it supports AWS the most. There's 30 AWS subcommands. There is Azure support. There's 5 commands, and my colleague Bastian is working on 3 more at the moment. And there is a dev branch with some work Bastian has done on the GCP side, but it's not in the main branch yet. So let's go through and do some of these assumed breach of an application type challenges. And to do that, what I'm going to do is I'm going to connect to, right? I'm going to connect to the Bastion host that is created for this purpose. So I've connected to, this is kind of I'm connected to an EC2 instance running in my Playground account. And let's see what the identity is on this instance. And we see that we are running as the identity Reina. So now the question is, one of the questions if you were doing a pen test, right, is what can Reyna do? Well, Reyna can, well, let's see, we have a command that can do that. So this is CloudFox's permissions command, and you could run this against all principal. Oh, I can't do that on the on the Bastion host. I have to do that over here. So CloudFox has a permissions command which can be run on all principals, but you can also specify the principal. So I'm just going to say just Reyna. What does Reyna have access to? And so you can do the same thing in the AWS console, but it's kind of nice to have this stuff at your fingertips. Because the way this, no permissions found. All right, live demo. Let's go ahead and do another challenge. Let's look at the nvars. Let's recreate the challenge that we were doing, that we saw previously. Okay, so we see that we have these environment variables, and we know that there's this RDS database with this endpoint, and we have the username and password. So this is really great, right? But from my laptop here, let's nmap it and see if we can access it. And it's filtered, right? Filtered from the internet. But let's see from this internal foothold, that same nmap, the same port is open internally. So just like we saw in the demo before, I'm going to use the MySQL command. I'm going to grab this password here. And so I just use the right database, and I spit out the credit card data, and here's the flag. Right, so this is just, I know we saw this already, but it's just to show you that's what CloudFoxable is all about. It's about recreating some common pen test type findings so that you can kind of practice this and kind of, get comfortable doing this type of work. Okay, so that's that one. Let's do one more. So this is a cool command called network ports, and it was contributed by Wyatt Gallenberg. And what this does, and this takes a minute to run, so I can kind of walk you through it. It looks at a bunch of different services, EC2, EFS, ECS, Elasticache, et cetera, right? It gets the IP addresses that are associated with these type of resources, but it goes one step further. It parses all the security groups and the network ACLs and gives you kind of like pre-populated nmap commands for each IP address. Because, right, as we all know, say, for instance, this EC2 instance is running on this port, but it's only accessible through on 12380. And if you think about it, on the pen test that we do, there's often hundreds of EC2 instances or ECS containers or things like that. And so this is really helpful in reducing the, who wants to scan 65,000 ports when only one of them is open? Again, a benefit of that white box allows us to provide more value in less time. So let's, I slightly modified that nmap command. And let's see. Okay, so I just nmapped that service, that EC2 instance on that port. And look at that. It came up as open. So now let's hope it is a HTTP service. And it is. It's an SSRF demo. I mean, this, you might think old news, right? SSRF in the cloud's been around forever. We still see this all the time in cloud-hosted services. So what I'm going to do here is, if anybody's ever done this, we're going to, the SSRF is in here, the URL. We're going to get the security credentials. So we go this far down the metadata service to find the name of the role. So we just got Wyatt. And then now we're going to, now is what we saw in the beginning. If we curl this, we get the token for Wyatt. So now there's two things we need to do. We need to figure out, well, what are these credentials, like what do they have access to? And two, we need to configure these credentials into, a profile on our other machine. So I'm not going to go do the second thing, but I will do the first thing. Because this is important. This is a lot of the art of pen testing. It's like exploiting one thing or another, getting access to a new role, a new principal, a new something, and then saying, okay, what new permissions did that give me? And so here we're doing the permissions command again, and you could see we have DynamoDB access to a particular table. And you guessed it, in this example, there is a flag sitting in that DynamoDB access, and we have permission to access it. So I think I wanted to leave with this one because this is really important, right? The post-exploitation steps totally are dependent, or not for everything, but for IAM-related exploit paths, are related to the permissions that you're given. So in this case, Wyatt had a DynamoDB access. In other cases, Wyatt may have the ability to download containers from ECR, from the container registry. Or maybe, if we get lucky, Wyatt has the ability to, update a layer of a container on an ECR repository, and you can kind of backdoor a container image. Or another one might be the role of this vulnerable service might give you the ability to update a CloudFormation stack. What can you do with that, right? Or create a new CloudFormation stack. So it kind of, you just follow this path, hopefully getting closer to your trophy targets. And I think it's a pretty fun process. So with that, I'm going to switch back over and wrap up with a couple of takeaways. One, I would say when possible, use account or project or subscription level segmentation. So account segmentation in AWS, project in GCP, and subscription in Azure. Use this segmentation, deploy different applications or different, business units into different accounts. You gain a lot of segmentation, benefits from that segmentation, basically for free. The next one is start using the principle of least privilege now, especially as it applies to workloads. It's very dangerous to have workloads running with admin or admin-like permissions, or just overly permissive, like S3, on every bucket. It's of course not realistic for a 5-person company to, get really in the weeds with principle of least privilege. Like, you have to move quick in the beginning, but don't put off using least privilege, indefinitely. Start thinking about how to do it now. And the easiest way to do that is with infrastructure as code, right? Everything can be variables and everything can kind of be attached in code. And if you need to change it, you can just do a find and replace. So that's definitely what I recommend. The companies that do this well at scale have to use infrastructure as code to do this. And then lastly, you should, of course, proactively identify your unknown attack paths. As we talked about with those role trusts, like there's just so many sharp edges where you give a particular resource a permission or you give a particular role a permission, and it kind of, the changes cascade in terms of impact. So you really want to, every once in a while, check to see if, an offensive-minded person can't find an unintended attack path in your cloud. And that's it. Thank you for listening to me talk tonight. I appreciate you all attending, and I'm happy to answer any questions you all have.
Cool. That was great. Thanks a lot, Seth. We have a few questions. I have some as well. So you talked about the difference between a configuration review and a cloud pen test. When do you advise people to do one versus the other? You kind of covered it a little bit, but we'd love to hear more of your thoughts.
Yeah. So I feel like everybody should be doing cloud configuration review. And I think that the best way to do that is to use a tool. CSPM, Cloud Security Posture Management, is kind of the class of tooling for this. And, some of them are open source, some of them are subscription, but it's kind of scoped to how big your account is. So I really do think that everybody has the ability to use these tools, and you should be, using them. Like, everybody should be using this as a baseline. And then I think once you've kind of handled the low-hanging fruit, or if you're just, dealing with a lot of really sensitive data and you know that there's considerable limitations with that configure view, then you're starting to think about pen testing. And I guess I'll add one more. There's red teaming as well, right? So the way I view it is once you have found lots of the attack paths with penetration testing, and you've matured to the point where you have a blue team. So when you're ready to test the detection and response capabilities of your blue team, that's when you're ready for red team in the cloud or otherwise. So that's kind of the crawl, walk, run that I like to talk about there.
Makes a lot of sense. And what are you seeing that's improving in the cloud, and what are you seeing that's either staying the same or getting worse when you do these tests?
Yeah, that's a good question. Improving is, I think, the ability, the way that you can apply permissions in such a fine-grained way is excellent, right? Companies that do this well, that really kind of bake it in. It's kind of like unit testing, right? Like it's kind of hard at first, but like once you start baking in, thinking methodically about the permissions that you're giving, you can be so fine-grained. Like we were on a pen test recently where we found they were still using long-term access keys, which is a no-no. You should be using temporary. But every single pair of keys that we found had access to one bucket. Like that's so cool, right? And the cloud makes that easy to do. So that's what I think this fine grain and Azure and GCP are the same, right? They all have this ability to kind of really be tight with your permissions. I think that's probably the best thing that it does well. What it makes harder is that with these resource policies and it's just so easy to overlook something that's just kind of like more accessible than you realize. I think people think about the EC2 instances and maybe the Lambda, but as people experiment with more services and more resources, it gets really complex, right? There's hundreds of services in AWS, and I don't know how many in GCP and Azure, and it's just that no tooling is looking at like the service that AWS released like last week, right? So if somebody misconfigures, like I think there's a service called like IoT Greengrass or something, right? Like I don't know many people that are using that, and I don't think there are any open source tools or maybe even commercial tools that are looking at that service. So that's kind of the tricky part, right? It's maturing at such a fast speed that it's hard to keep up from a security perspective there.
Yeah, for sure. Ben, any questions from your side?
I'm all good. I've been trying to follow the chat as well too, and I don't see anything really there.
Cool. Yeah, one. Go ahead. Sorry.
Oh no, I was going to say somebody asked for the terminal size to be bigger, but I that was a little bit too. You wanted to convey all the information on screen, so I didn't interrupt you to.
No, I know it's always tricky for sure.
Yeah. One last question before we wrap up. What's some of your favorite targets or kind of the most juicy targets when you do these types of tests? What are the things you're always excited to see?
So I covered on this talk more of the application compromise side. But honestly, what I have the most fun with is when there's a principal, a person involved. So it says, we give our developers VPN access. What can you do? Like, can you get admin? Or we don't give anybody access to Kubernetes directly. We just give them access to Argo CD. Is there any way that you can use Argo CD to get access, like, admin access in the cloud, right? Or, maybe we give them access to Kubernetes, the Kubernetes clusters in the cloud, but not the actual cloud itself. And so those are the really fun ones, right? Because you're really, like, they've made assumptions, they've put security controls in place, and it's just a game. It's just, like, can I think outside the box enough to find an attack path that they didn't think of?
Yeah, makes sense. Awesome. Well, thanks so much for taking the time to do this talk. It was really interesting. And yeah, thanks for joining.
Yeah, thanks for having me. I really appreciate it.
Cool. Great.